All right, so in this problem, I'm going to have a rocket. All right, so that's my rocket. And the rocket is going to have a weight. And the rocket is going to accelerate upward at 6.1 meters per second squared. So I'm going to need an applied force bigger than the weight of the rocket. So if I label these things here, I'm going to have the weight is going to be 15,300 newtons. And the applied force is what we're looking for. And the acceleration in the problem is given as 6.1 meters per second squared. So that's pretty much your picture. Okay, you've got the applied force up, you've got the weight down. Now, if I were to apply, let's say, a force of 15,300 newtons, then the rocket would not move, it would stay where it is, or if it was moving, it would stay at that speed. So if the forces are balanced, it's not going to speed up or slow down. So I have only one descriptive equation when I do this, and it's going to be when I sum up my forces, I've got two forces in the vertical direction. Now, if you want to write some of the forces in the y, you can, but there's really no need because we only have one direction in this problem. So we sum up our forces, we're going to get Fa minus W equals Ma. That's our equation. That's our descriptive equation. And the Fa is the unknown. Now, they didn't give me the mass, so somewhere here I should calculate the mass, because if I look at my equation here, I'm looking for that. I know that, and I know that. The only thing I don't know is the mass. So I'm going to solve that. The mass is going to be W divided by G. So that's going to be 15,300 newtons divided by 9.8 meters per second squared. And that's going to be what? $1,561. And so now that we know that, we're looking for the applied force. So if I rearrange the equation above, the applied force is just going to be Ma plus W. And then you plug in the numbers. We're going to have Ma plus W. The mass is 1561 kilograms. The A is 6.1 meters per second squared. And the weight is 15,300 newtons. And solving that, and that answer came out to be 24,822 newtons. So that's it. So vertical motion don't involve an awful lot. You don't have to do trig. The picture is fairly simple. There's only one descriptive equation, and really there's not a lot of work. When you look at the board now, there's not a lot of work that needed to be done to come up with that answer. All right, any questions?